Alright, I was just getting something out of the way here. This is a video to kind of show us how to set up the circuit for layout and attaching the correct footprints. There's one other thing I want to delete here. I've built most of the circuit already. We've got D1N4001 diodes, electrolytic capacitors. Notice that I've made here the 1100 microfarad capacitor electrolytic. The 0.1 microfarad capacitor is not. I can tell because there's a plus here making that electrolytic and there's not here. That's important because plus ones, it matters what direction you put them in. So we've got that. Now there's a few things I've left out here on purpose because I want to finish this layout here and get, or the circuit diagram, and get it prepped for layout. Now you're going to need some additional libraries that you might not have installed, but first off let's just do the LM317, and you can quite frankly use any of the 317s, but we're going to have to do an adjustment on this. So we're going to use the LM317K op amp, and I'm just going to place it right there into my circuit schematic. Now, looks like everything's fine, but it's not. Let me show you why it's not. I'm going to open a web browser here. This will take a second because my computer's sometimes a little slow. And it opened it in my other window. And I'm going to shrink this down a little bit because I don't need the full screen here. And I'm going to type in LM317, well, datasheet, but I'm just going to look at the Pinout diagram for this. And let's just look at this first image right here. Come on. There we go. So I'm going to look at that here. Now, what do you notice here? Is it has pin 1 as adjust on the LM317, pin 2 as the output, and pin 3 as the input. What do we have here? We have pin 1 as the adjust, pin 3 as the output, pin 2 as the input. Now as far as the circuit simulator is concerned, it doesn't carry what pin is what number, but in layout it absolutely difference here. If I weren't to change these pins to match what the layout is here for the 317s, we'd connect the circuit up and it wouldn't work properly because you'd have, so we need to make sure to swap where the input and output pins as far as their labeling goes. Select the part by clicking on it, right click and go to edit, and it's pretty straightforward. We're going to make this, well, the input we said was pin 3 and then the output is pin 2. So we just change that. Then we'll close this tab and it will say update. Well, you can do update all or update current. Update current only does the current part you're editing. Update all will do all instances of the LM317 in your circuit. We only have one, or update all. And so take a second here. My computer's running a little slow. And you can see it switched the pins out. And if we go back here, yes, that is now following the pin out of the 317. So that's very important to make sure to do. Here, this value of 500 voltage that gives you, I put that there on purpose so that I didn't give you the resistor value. 100 ohm, this resistor here, that's typically because you want to have this resistor, and it says so in the data sheet. You want this in the 100 ohms range. You can have it not be 100, you could have it be something like that, or actually 200 we don't have, but like 220 for instance, depending on what you decide in your computations you need for those resistors. Alright, so what else do we need here? Well, we need connections for the output. We're just going to simply put in a 2-pin header here. So, as far as where the LM317 is located, as far as the library, it's in the op amp library. So if you do not have the op amp library installed, see I have all my libraries. The op amp library installed, you need to install the op amp one. So then I'm going to go to header 2, And again, if you don't have, this isn't, you can see on my video here all the libraries because it's got the component name and then the slash. This is the connector library. So if you start typing in these parts and you don't see them pop up, that's because you don't have the libraries installed properly. So I'm going to just place this. I'm going to first flip it and just connect it up right there. So I don't know why there's a little node connection there, but that's fine. And that's what we're going to use as far as connecting input to, and I've even got that labeled. Now we have the transformer here, and I know we had some issues in the labs with some of the transformers. Those should all be corrected, hopefully. Okay, I took a pause in the video recording there. So the transformer that you need here, because it's the one that we have in the lab that you'd be using to assemble your boards, are TRN-SFMR SP-68. And that, I've actually highlighted the library that I'm in for that. I'm in the discrete library. And so I'm going to highlight, and the reason we need that one is it's got the proper pinouts and everything and connections. These are typically how a lot of the transformers are now, where you'll have a single primary winding and 2 secondary windings. So that's the transformer we need. And then one thing that when you were building these circuits that the transformer boxes, and I know they didn't all work properly, they will next time, is we need a fuse. And you saw I might have deleted it. That's also in the discrete library. And so I need a fuse. So I'll put my fuse in there. That's basically just to protect the circuit, and if you start drawing too much current, basically the fuse, it's a slow blow fuse, but basically, so if you have like too much current or spikes of current, that's basically what it will prevent things like that from. And the other thing we need is an AC plug, which I can't remember if AC or if it's plug. Yeah, it's plug. AC female connector. Quite frankly, you could use the female, or if you look here, you could also use the male connector one. It's fine. They're both the same. As far as the receptacles, they are different, but as far as the pictures, they're essentially the same. I used a male connector when I did this, and then I'm going to rotate it and connect it like that, and so you can see we've got neutral and hot coming in, and then this ground pin, I just used an X saying it's not being connected to anything. So this will be the circuit then that we would want to create our layout for. Now remember, one thing we have to do now is once we have our circuit built, you want to edit the part and go to your footprints. Now I had my pivot table already done, so you might get it to look like this, and remember you can just hit the pivot, and we want to go down to PCB footprint. Now I know that you'll have some things listed here. I have nothing listed here right now because I deleted everything on purpose. So one thing you can do is you'll have some footprints installed on them, and they quite frankly should have all the footprints that you need. If they don't, I can make sure to make those available. Turned around in a second here. Where am I at here? I want to go to Dropbox, Cadence, and Footprints. Alright, so for the capacitors, well, oh, there's one of the things we forgot about, is we have to determine, we have one other thing I forgot to do here. Capacitors, and we have C1, C3, and C4 that are electrolytics. And we actually have to edit the part on those because these electrolytics are a little weird. Remember, they have numbers that are like P for positive. That's pin number. And then you also have to change this. And if you don't do this, it's not going to work properly. And then I'm going to close and update all. So anytime you use an electrolytic capacitor, you have to make. And once it updates all, okay, there we go. Now let's go back into the footprints. I did now. So we're going to go back in, select all, edit properties, do the little parts tab there, and then footprints. Now it tells me what kind of value these are here, 100 microfarad capacitor. And so the PCB footprint that you'll want to use, and I'll even just kind of bring it over here. You see you'll have a footprint directory that will have a lot of these already in here, and if you have it, it's a quick way to do this. I'm going to use the cap underscore lect, and I'm going to simply say rename it. I'm not going to rename it, but I'm just going to do Control C to copy it and put it in there, Control V to paste. And then I know that I'll just type it in though this time, cap underscore disk. And then we also have another, those aren't as big though, so we could get away with using the smaller size, cap 6 underscore 5 for C3 and C4. Diodes 1 through 4, these are 1N4XXX diodes, so this will work for all of the 1N4XX, and what I mean by that, there's 4001, they all have different current ratings, I believe. Or no, they're all the same current, they have different voltage ratings, is what they are. So put those there. F1 stands for the fuse, which you may have seen if I footprint called fuse. J1, we're just going to call that jumper 2. We're going to just do a 2-pin jumper. Or actually, instead of doing a 2-pin jumper, you can do jumper 2, but if you have this one installed, this basically means you're going to and solder the wires in, but it makes it a little bit easier to make the connection. So if you want to do wires into your board, you would do the 2-wire. If you want to have a nice little 2-pin header, you would do jumper 2. So I'll leave it for now as the 2-pin header. So jumper 2. If that is correct, yes. And I've got, oh, J2. I'm like, what is J2? And I should have just looked here. It's the AC plug. And you saw in my footprints here, probably did, I have an AC, so I'm just going to do again the rename idea, rename, and I'm going to copy that, and then I'm going to, oops, not place it there, place it in the footprint category, and then resistor 500 that I'm going to use here, except maybe resistor 500, make sure you spell it right. And then the transformer for summer. And then the LM317, I believe I've got one here. It's LM317. The heat is that I've made the footprint to account for putting a heat sink on the 317 because those things will get hot, and so you may need to put a heat sink on it, and so that's what that footprint is, just including space for the heat sink. And then of course once we've updated all those, we'll close this out, and then we'll make sure to save our document. You might want to save at many points beyond this, because I know sometimes these things, programs can crash on us. Alright, so I'll click save again, and then remember to create, the next thing we have to do here is go back to the power supply and select the DSN file, and if you haven't yet, you always need to annotate first, and you just annotate, and it'll say, do you want to do this? Yes. And it says this one's already been generated, so of course, you know, don't have been generated. And then once that's done, we do create netlist, and it's going to store it in the Allegro directory. We don't need to change anything here, and we click OK, and according to plan we'll have this little show up, and then we'll have a little green